Hello, my name is Andrew Kucher, and today I'm going to be solving problem 10, not 10, 12.2 from Fundamentals of Heat and Mass Transfer by Bergman and Levine. So for a brief rundown of the question, a horizontal opaque surface at a constant steady temperature of 80 Celsius is exposed to airflow with 25 at 25 degrees Celsius with a convection heat transfer coefficient of 20 watts per meter squared Kelvin, and the emissive power heat flux of the surface is 628 watts per meter squared, and the irradiation of the surface is 380 watts per meter squared, with a reflectivity of 0.3. You're asked to determine the absorptivity of the surface and the net radiation heat flux for the surface, and answer whether or not the heat flux is from or out of the surface, and also the combined heat flux for the surface with convection included, and whether that is as well from or away from the surface. Well, here's what we're given. We're given E, the emissivity, G, the irradiation, and the rho, not absorptivity. Uh, Rho is reflectivity in this case. So this isn't density in this case. We're also assuming the surface is opaque at steady state and constant properties, of course. And you can see what I just put right there. Q double prime rad, Q double prime S, and alpha of the surface. So to determine alpha, because it's an opaque surface, there is no a tau part of this equation. Normally, this equation would be 1 equals rho plus alpha plus tau. Uh, it's at the beginning of the fundamental concepts. Right here. Transmission of irradiation through the surface. There is none of that because it's an opaque surface. So to get the alpha or absorptivity of the surface, we just need to basically subtract so 1 minus the reflectivity of the surface will give us the absorptivity. So alpha is 0.7. Now, for the heat fluxes, well, they already give us the heat flux, so you don't really need to do much calculations. It's just the radiation heat flux is for the surface is going to be the emissivity minus the irradiation times the absorptivity. So you can see the 628 minus 0.7 times 1380, which in this case is negative because uh, which in this case means that the radiation is going out of the surface. Because radiation typically assumes your heat is going into the surface, not out of the surface, unlike with convection. And as you can see here, for the convection, it's just your standard heat flux for convection. So H times the temperature difference between the surface and the air, which is 80 minus 25. The surface is hotter than the 80 degrees. Obviously, that's a lot warmer than the air temperature. So heat is going to be radiating outwards into the air. So that's going to be 1100 watts per meter squared for the convection. And when you add those two together, since the radiation is also going out of the surface, you'll get a total combined heat flux of 1438 watts per meter squared. Again, going out of the surface. Thank you for listening. Have a nice day.